Hi, so for the next part of the video, we're going to go a bit deeper into technical side, which is dimensional coordination or DC. So DC is a 3D reference system made up of points, lines, and planes. It is used to design, manufacture, and assemble components with precision. DC or dimensional coordination, defined as a convention, which is an understanding for the coordination of the dimension of building components. So basically, it's a understanding um, on the of the participants of the convention on the coordination of dimensions. So there is a coordination of dimension of the components and incorporating them in their design, manufacture, and assembly by means of three-dimensional spatial reference system of points. So basically, this coordination of dimension is accepted by the manufacturer, and also the assembler in in assembling the components. So the coordination is in three-dimensional spatial reference system of points, in term of points, in lines, and also planes. So there is a coordination between the of the dimension of planes, dimension of points, coordinate, and also dimension of line. uh, which dictate the size of components. So why is this important? So DC is important because uh, it simplifies design and also simplifies the documentation procedure. So the design and the documentation of the design will be a lot simpler as there is a coordination, there is a petition uh, between the components during designing. So the design will be simpler, and also the documentation of the design is also simpler, and this allows the implementation of computer techniques. So we use computer aided design as the components are the dimensions are repetitive. So this can be seen in beam of Revit beam software. So you see a lot of software that just input the components. So the computer the design already know what type of components, the dimension of the components. So it helps the designer in determining the next part of the design as the components are well coordinated in terms of dimension. And next, it can achieve optimum efficiency in the manufacture and use of components and assembly. So basically, the manufacturer will avoid wastage or having too many molds to produce the components as the sizing are coordinated. So maybe it is a incremental of 3M, 6M, and so on. So it allows optimum efficiency in producing it and also optimum efficiency in assembling the components. Furthermore, after that, you will be avoiding cutting or modifying components and uh, assemblies on site. So there's less wet work, there's less cutting. So components are well fit together on site to form a structure. And then it reduce non-standard or dimensionally incompatible component assemblies. So there is will be less non-standard or dimension incompatible. Only a few, maybe a few section that you cannot change as the it requires by the design. So maybe some of components that need to be non-standard, but most of the components will be standardized. So this allows much faster construction. Now, what makes a good module? What are the characteristic of a good module? So you can have, Malaysia, we have a standard of MS1064. So the experts that come up with the MS1064, uh, you know, uh, specify the modules for Malaysia. So you can have another module in other countries, but A good module need to have a good characteristic lah. So we're gonna go through a good characteristic of a module. So first, the module should be small enough to allow design flexibility. So the sizing 1M, 3M, for example, Malaysia is 1M is equal to 100 mm. So you can have one module is equal to 25 mm. If you prefer, but on Malaysian standard is 100 mm. So the sizing 100 mm is very small now, 4 inches. So you can have the incremental. For example, you have a beam of wide 300 mm, the width of 300 mm. So you can have a 3M. So it's easier to specify, and also your design can have like, for example, 350. So it's a 3.5M. So there's a flexibility there for you, for designer to specify their sizing for their components, beam, doors, windows, and so on. And then next one, a module should be ergonomically designed to promote efficiency. So the components are designed ergonomically. The module can be suit to design a component that is ergonomic, for especially when we talk about ergonomic, it relates to human nature. So that module needs to be can be suit for ergonomic design. Next one is industry friendly and features that not only cater for manufacturing but also the transportation and assembly requirements. So you have a requirement on transporting and assembly. So it shouldn't be long enough, too long, that it it will be hard to transport, and then maybe it's too large that you can't, you can handle the object during the assembly. So these are need to be um, considered during coming up with the modular. And then the last and not least is to be internationally accepted, so that you can have a support from the foreign, international supplier, and you can have all sorts of components that fit your module. So then these four needs to be considered in coming up with the module. So MC, modular coordination, is not just a design tool. So it's a concept that applies across the entire building process, from designer in designing the components to manufacture the components, supplier of the components, and then to the assembler. So MC influences how we position and size, specify the dimension of the component. So it even affects how we work on site. And here's something interesting. MC allows for relative independence in decision making. So as long as everyone uses the same dimensional language, 1M equals to 1mm, teams can work autonomously yet still stay coordinated among the parties. So as you can see in the figure here, we can see there's roof, uh, prefabricated wall, prefabricated column, prefabricated flooring. So these are all coordinated between the designer, the design, the size of wall, column, engineers design the column or structural components, uh, and these all come together as the coordination are well versed by all the parties involved in the designing and producing the component and assembling the components of the building. So next we're going to talk about more on modular coordination concept, and also what are the components that we need to really uh, s- go through in coming up with the modular coordination uh, related to civil engineering. So in the previous video, we have talked about the what is modular coordination, what is dimensional coordination, what are the good characteristic of module. What are the modules? So in this part of the video, we're going to talk about the big picture, the concept of modular coordination. So the main objectives of modular coordination are to improve productivity, um, reduce waste, and then to improve the streamline installation of the components. But all in all, what are the core rules of modular coordination? So first, we use modules, the use of modules, the basic modules and multi-modules uh, is the main components of modular coordination. There's a modules and then there's a reference systems. So reference system define the coordinating spaces and zones for the building elements and for the components which form them. For example, you have floor to ceiling. So floor and ceiling is the reference system. So there is a floor to ceiling is, for example, 20 m. So that is the coordination based on the reference system. There is a modules, and then you need to have a reference system, and then the rules for defining preferred sizes for building components and coordinating dimensions for building. So you have components, you have building dimension, you have floor area. So the modular coordination would specify what are the preferred sizes. For example, preferred sizes for door, preferred sizes for windows, and then modular coordination also specify the preferred sizes for building. For example, the floor to ceiling height. What are the preferred sizes? 25 m, 30 m, and so on. So the fourth one is the rules for sizing building components in order to determine their work size. So you have components, but you need to also have their work size. So modular coordination specify the component including the work sizes. For example, you have a finishing in front of on the surface of wall. So that are the work sizes. You have a jointing between components. For example, you have railing. For example, for prefab wall, you have railing. So that railing will be included to the dimension, the height of the wall, and so on. So there is a work sizes that will be defined by the modular coordination system. So, and the last one is rules for locating building elements. So how do you locate your building elements within the reference system? Uh, these are all the rules that we provided by the modular coordination. So these rules create consistency, reduce errors, and then make the entire process more predictable. So designer knows that when they specify components, they also need to specify the work sizes, how it being assembled together. So the assembly know the jointing and so on. So these are where coordinated by the modular coordination. So based on that rules, that five core concept of modular coordination, what you can see is that uh, modular coordination is very important. The benefits that comes with the MC modular coordination, uh, it clears to us that construction needs to have that sort of coordination between the designer, the fabricator, the assembler, and the supplier, and so on. All the parties involved in constructing a construction project. So why should we care about MC, modular coordination? Because it makes construction cleaner and then faster, and then less wet work means fewer delays, less dependence on skilled labor, means more better quality because it is being produced by skilled labor with correct uh, tools and environment, and also a few modification on site, which means lower cost, less wastage, and so on. As you can see here, first it improves productivity. There is a standardization with the components and building dimensions, and then it promote industrialization. There will be industrialized building system, rapid production, rapid construction of building, and then less work on site. No non-dependence on unskilled labor, and then less modification on site. So MC promotes standardization, which in turn support industrialization. Then it's a win-win for everyone involved. So overall, the big picture on MC modular coordination is that MC is an important factor in application of IBS, industrialized building system, by way of standardization of components and dimensions, such as reduce of time production, installation of components, achieving repeatability, and able to construct building at lower cost, as we reduce the wastage, reduce delay, improve efficiency of construction. So we will reduce uh, the cost of building. So the main objectives of MC are to improve the productivity, reduce waste, streamline installation, and then enhance quality. It also encourage an open system, meaning components from different sources can be assembled together. So in Malaysia, MC plays a very key role in industrialized building system (IBS). Uh, it helps us build faster, more affordably, and with repeatability quality. So you can see this being implemented in especially in mass housing project by the developer, as in Sri Pajam, in Gamuda, as they see that this reduce the cost and improve efficiency, in turn giving them much more profit, in mass housing. So Malaysia has its own standard for modular coordination. We have, as we talked about before, MS1064. It's a comprehensive guide with 10 parts. As you can see, 10 parts. So the 10 parts cover everything from the story heights. And then part 3, you have a stairs and stair openings. So as we talk about MS, the modular coordination will give you the preferred sizes. How do you place your stairs between what reference system and so on. So part 4 is door sets, 5 window sets. So it covers from the story heights towards the stair openings to the window styles, and then reinforce concrete components on part 10s, which really involves very relatable to civil engineering. So this standard ensures that building across the Malaysia country follow consistent modular principles, so making construction environment more efficient and scalable. So the first part of the MS1064, part one, covers the general principles, the horizontal and vertical coordinating dimensions, and also covers the joints. And these sections help designers and builders apply MC consistently across different building elements. So it covers the principle, the foundation of the sizing coordination. How do you plan your horizontal dimension, your XY, and then the height vertical coordinating dimension, and also the joints between the components. So it is the starting point for anyone looking to implement the modular coordination in their projects. So now that we've covered the principle and standards, let's move into the technical application. We will explore how MC is implemented in the horizontal and vertical planning, how components are sized, and how reference system guide the positioning. So this is where the theory meets practice. You need to convert. In the end, we want you need to be able to convert the conventional dimensioning into modular coordination dimensioning. So this is where the theory meets practice and where MC truly shows its values. So see you next video.